Okay, so for this circuit, we have to find the formula for I. So this I value here for when t is greater than 0. And we're going to assume that this switch when t was less than 0 was closed for a long time. So let's find the formula for when t is less than 0. Okay? Or let's find, sorry, the current when t is less than 0. So the circuit will look like this. This one will be 10 volts. This is 2 ohms. This is 3 ohms, and there's a current passing through here. This 1/3 Henry uh, inductor. Now, since there's this wire here, all current is going to be going through this wire and skipping this resistor because current will try its best to not go through a resistor. So we can pretty much ignore this 3 ohm resistor. Oh, wait, okay, we can pretty much redraw it like this, and we're going to make the assumption that the switch was closed for a very long time. So to find the voltage at this inductor, it'll be equal to the inductance value times the change in current over the change in time. So time goes to infinity, so the voltage is 0. So that means we can do a short circuit here. Now we just have to solve for I. We can just do so we see the voltage is 10 is equal to 2 times I, the resistor. So I will be 5. So when t is less than 0, I will be 5. Now let's write the circuit for when t is equal to 0. When t is equal to 0, the switch is opened. So the circuit will look like this. So it looks something like this. And since it's an open wire, we can just ignore this part. So this is 3 ohms here, 2 ohms here, and 10 volts here. Now, the current moving through this capacitor, so when t was less than 0, it was 5 amps. So when the second t is equal to 0, the current passing through the current passing through the inductor, if I said capacitor, sorry, it was inductor, my bad. The current passing through the inductor can change instantaneously. So the current at t equals 0 is still 5 amps. Okay, now let's focus on when it's greater than 0. So when t is greater than 0. So the voltage will be 0 because the inductor times the change in current over the change in time thingy I said earlier. So the voltage equals the inductance times the change in current over the change in time. We're going to make the assumption the time is infinity. So the voltage will be 0. So we can short circuit here. And now all we have to do is solve for I. So it'll be 10 equals 2 plus 3I. So it'll be 10 over 5, which will be equal to I. Okay? And this is 2. But this I value does not represent when I is greater than 0. This I value is for I infinity. Okay? So now we can solve for what this IT value is going to be. So the formula for I. So what we know about the circuit is that there was always a source whenever the switch was on or off. So when the switch was on, there was this source involved, and when it was off, the source was still involved. So to solve for the formula for I, we have to use this scary looking formula. IT is equal to I infinite plus I of 0 minus I infinite times e to the power of t over the time constant. So the time constant will pretty much be the time constant is equal to the inductance over the resistance equivalent. The resistance equivalent will be between the inductance terminal. So we obviously turn off this source, and it's the sum of all the resistors. So 2 plus 3 is 5. So the resistance equivalent will be 1/3 over 5, and that's 1/15. So that's your time constant. So to find I of t, it's going to be I infinite, which is 2, plus I of 0, which was 5, minus 2, times e to the power of t over 1 over 15. So I of t will be 2 plus 3e to the power of 15t. And this is in amps, and this is your final answer.